Very good day to you all, students. I'm very happy to be here once again. I'm sorry for the delay of this stuff. I have some complication about the system that I'm using for my online class. Yeah, I am S.Adebayo, still taking you chemistry today, and today we shall be talking about electrolysis and ionic theory. Electrolysis and ionic theory. And under this, we shall be discussing the meaning of electrolysis and terminologies that are attached to it, like electrodes, electrolytes, electrolytic cell, and the likes. We compare electrolytic cell and electrochemical cell, and what are the principles of the electrolysis. Thereafter, we talk about the factors that affect the discharge of ions and the products of electrolysis. We talk about the examples of electrolysis, the examples of electrolysis. We use the acidified copper 2 devices, and the brine. Now, ionic theory. Let's quickly talk about ionic theory. Ionic theory was used to explain the behavior of electrolytes when electric current is passed through their solution. A Swedish chemist called Svante Arrhenius in 1887 was the first person to present the ionic theory to describe electrolysis. The theory proposed that when an electrolyte is melted or dissolved in water, some, if not all, of the molecules of the substance dissociate into freely moving charged ions. That is, positive ions called cations and negative ions and anions. The process of dissociation into ions is called ionization. That's the first thing I want us to learn here. Any electrolyte is a molten or a solution, so a compound in its molten that can a compound that can conduct electricity. That's what we call a simple electrolyte. Now, whenever an electrolyte is dissolved or melted in water, some, if not all, of the molecules of that electrolyte will break down, will dissociate, will dissolve into freely moving. For instance, if you have sodium, an example of an electrolyte is sodium chloride. Whenever you will dissociate sodium chloride, it breaks down to give sodium ion and chloride ion or chlorine ion. Now, that is what we call dissociation of electrolyte. And that is exactly what we call ionization. So when an electrolyte is melted or it is dissolved in water, some of, or if not all, of the molecules dissolve into freely moving charge. It can be into their corresponding cations or corresponding anions. And the process of this dissociation is called ionization. So ionization is the breaking down of the electrolyte when it is dissolved in water or when it is melted. Breaking down of electrolyte into their component ions. Breaking down of electrolyte into their component into cations or anions. You can also say it like that. When dissolved or when melted. That's what we call ionization. When an electric current is passed through an electrolyte, the free ions lose their random movement. The positive ion become attracted to the negative electrode. That's exactly what we're going to be talking about. The positive ion will be attracted to the negative electrode. That is what we call cathode. While the negative ions move towards the positive electrode. That's what we call anode. Don't forget, the positive electrode is anode and the negative electrode is cathode. So whenever we pass electric current through an electrolyte, the free ions, they lose their movement, random movement. So the positive ion of that electrolyte will now move towards the negative electrode. We move to the cathode. While the negative ions will move to the anode. It is this ionization and mobility of ions that constitute current flow. I'm just explaining the ones that form the building block of this. Arrhenius version of the ionic theory has been modified since the X-ray diffraction studies show that salt and strong alkalis consist of oppositely charged ions, even in the solid. The modern theory of the proposes that ions in such some solid state are pulled away from one another either as a result of heat energy applied when the solid melts, or when with the help of the solvent molecules when the solid dissolves. Now, the Arrhenius theory said that when it's NaCl, for instance, solid dissolve, we have Na plus and Cl minus. But the modern theory says that Na plus Cl minus dissolve to give Na plus equals plus Cl minus. Now, let's talk about the meaning of electricity. We have been able to talk about electrolyte. That's exactly what we discussed in this first section. Electrolyte, ionization. Electrolyte is the substance that when electricity is passed through it, it dissolves, dissociates into their component ions. So we said that we'll talk about ionization, and we'll talk about how electrolytes break down to give their components ions of when their mobility or their the random movement is being broken. Now, what's the meaning of electrolysis? That because this topic is even electrolysis. What's the meaning? Electrolysis is the process whereby chemical decomposition occurs when an electric current is passed through an electrolyte. Electrolysis is the process whereby chemical decomposition occurs when an electric current is passed through an electrolyte. Let's look at some terminologies of electrolysis. Electrode. An electrode are conductors in the form of wires, the wire rods or plates, through which an electric current enters or leaves the electrolyte. We have the cathode, and as a cathode is the negative electrode, and the anode is the positive electrode. So, electrode are conductors in form of wires through which electric currents can enter or leave the electrolyte. Note, in an electric cell, the negative electrode is known as the cathode, and I've said that, while the positive electrode is known as the cathode. In an electrochemical cell, the negative electrode is the anode. You can see in electrolytic cell, we are going to be talking about the difference between this electrolytic cell and the electrochemical cell. In electrolytic cell, the negative electrode is cathode, but in electrochemical cell, the negative electrode is the anode. While in the electrolytic cell, the positive electrode is the anode, or while in the electrochemical cell, the positive electrode is the cathode. We are going to be discussing about the difference between the two cells in our subsequent classes. Then, electrolytes now. That's the second terminology. An electrolyte is a compound in a molten or an aqueous state which can conduct electricity and is decomposed in that process. Any material, any compound that has the tendency of conducting electricity and then get decomposed in that process of conducting electricity, that particular substance is an electrolyte. It can either be in a molten form or in an aqueous form. And we can have electrolyte to be a weak electrolyte and a strong electrolyte. A strong electrolyte ionizes completely. And it's when all the elements, all the compounds ionizes completely and conduct very large electricity or electric currents, since they are composed of entirely free moving ions. When we have any electrolyte in such a way that all the free moving ions are given up, or all the molecules ionize completely, then such electrolyte is a strong electrolyte. Just like when we have all the strong acids and strong bases and strong salts. But weak electrolytes are the ones that when they are decomposing, they do not completely ionized. They are partially ionized and they do not conduct electricity so largely. So any electrolyte that's partially ionized and conduct electricity poorly because they contain low concentration of ions, they are called weak electrolytes. An example of that are weak acid and weak bases. A non-electrolyte do not conduct electricity since they do not ionize. So we said that electrolytes are sometimes, whether in molten or aqueous form, conduct electricity and yet get dissociated or get ionized in the process. So, but the non-electrolytes are the substances that do not conduct electricity and they will not ionize. Example is the urea, ethane, benzene, trichloromethane, cane sugar, ether, tetrachloromethane, and so on. These are non-electrolyte. They can never conduct electricity and they will never dissociate. Electrolytic cell. This is where we are going to. In an assembly of two electrodes, electrolytic cell is an assembly of two electrodes in an electrolyte and is used for the electrolysis of substances. The diagram we are seeing here is a typical diagram of electrolytic cell. You can see this one. This is typical. We have look at the cathode, positive, the anode. You can see the two of them. Let me see if I can have something. This is, you can see that's the anode. This is the cathode. This we can see this container is the electrolytic cell. You can see the electrolyte. That's the that's the electrolyte inside it. You can see the label. You can as well follow the zoom the whole diagram and check. Let's look at the second one. The second one. This I want to give a typical example of electrolyte. Sorry, electrolytic cell rather. I think you can see that. You can check the labeling. But the second one, this one is more far clearer. Now let's quickly look at some evaluation questions. Let's have by now you must be able to answer these questions. Write short note of the following: what is electrolysis? Electrolysis, electrolyte, electrodes, weak electrolyte, strong electrolyte, and non-electrolyte. Let's compare the two that I've been talking about: electrolytic cell and electrochemical cell. We said that the electrochemical, we said that the electrolytic cell is okay. Let's look at the table. Then we'll fall back to the diagram. Number one, electrolytic cell convert electrical energy to chemical energy. That's number one thing. Electrolytic cell convert chemical energy to chemical energy. And the electrochemical cell convert chemical energy also. Sorry, chemical energy to electrical energy. You can see the reverse. Electrolytic convert electrical to chemical energy. That is, electrical energy is required. Electrical current is required for the reaction to take place. But in the electrochemical cell, it converts chemical to electrical. That is, chemical reactions produce electrical energy. You can see the reverse. Under the electrolytic cell, it is the electricity that is needed to power the cell. But under the electrochemical cell, it is the chemical reactions that produce electrical energy. Number two, under the electrolytic cell, electrons are forced or pushed by an outside source, such as battery. Is a cell that is powered by electricity. So power is supplied by a source, such as battery. And this process is a non-spontaneous. And under the electrochemical cell, electrons are generated by oxidation at an electrode. The process is spontaneous. The cathode under the electrolytic cell, the cathode is the negative electrode, while the anode is the positive electrode. But the reverse is the case under the electrochemical cell. Cathode is the positive electrode, just the reverse. And the anode is negative electrode. Under the electrolytic cell, electrodes are in the same compartment. But under the electrochemical cell, electrodes are in the separate compartment. I think we can see that one in this diagram. Okay, this does not even show that very well. Okay, this is that diagram does not show it very well. Let me see if I can see the subsequent ones. Anyway, such bridge is not needed in electrolytic cell. We don't need such bridge. But electrochemical cell need such bridge. Only one electrode is used under the electrolytic cell. Two electrodes are used under the electrochemical cell. This table, there are 6, shows the difference between the electrolytic cells and electrochemical cells. 6 of them. Please note them. You can watch this video over and over for you to get the understanding. Cations and anions. What are the principles of electrolysis? and an electrolyte composed of positive and negative ions. You know, I told you that whenever an electrolyte is broken down or dissociates, it dissociates into their component ions, and we have positive and negative ions coming together to form the compound. So during electrolysis, electrons move from a negative pole of the battery to the cathode, making it to be electron rich and negatively charged. Hence, positive ions migrate to the cathode and are called cations. The anode becomes electron poor and positively charged. Hence, negatively charged ions migrate to the anode and they are called anions. What are we saying here? Excuse me. During electrolysis, electrons move from the negative pole to the cathode and then become negatively charged. Positive ions migrate to the cathode and they are called cations. And anode becomes positively charged. That is when the negative charged ions migrate to the anode, which are called the anions. We shall understand this one better. What are the factors that affect the discharge of ions? Because you know we said that in electrolysis the ions are discharged as a matter of passing electricity through them. When you pass electricity through electrolyte, the electrolyte dissociates and break down and give off the ions. So what are the factors that are now responsible or that can affect the discharge of ions under electrolysis? And there are the factors here that I put in a summary form. The first factor is the position of that ion in the electrochemical series. Position of the ions in the electrochemical series. The ions we have electrochemical series which shows the preference or the power of each of the ions. You can, the table you are seeing here, the left here is the cations electrochemical series and the right here is the anions electrochemical series. First one, the most powerful positive ion, which is cation, is potassium, followed by the sodium, followed by calcium, and goes down in that order. What actually does this mean? It actually means that when we have a compound containing of calcium and we have a compound containing of potassium, potassium is likely to preferentially discharge because potassium is more stronger, more electrochemically stronger than the calcium. That is why potassium is on the top. You can see potassium is on the top of the electrochemical series than the calcium. The same thing are the anions, the hydroxy ion, followed by iodine ion, followed by bromine ion, followed by chlorine. These are the hierarchy in the order of position. So with hydrogen now, hydrogen ions, for instance, if hydrogen ions are in a chemical reaction with with potassium ion, potassium will discharge preferentially to hydrogen because potassium is more higher in the electrochemical series than the hydrogen ions. Are we together? And that's exactly what we call the position of ions in the electrochemical series. So please, this is electrochemical series. Let me just zoom in so that you can write them down in your notes. This is the order of the hierarchy of the electrochemical series. You can screenshot and write, and you can put them down. Electrolysis of sodium chloride solution using inert. I don't want to rush you. I will want to start from this in our next class. Electrolysis of sodium chloride solution using inert electrode. So I want to believe that you have gained one or two things. And in view of that, there are some questions I think we need to put through to you. Let me see. This is the question. You can screenshot and write them. I want you to look at this question and see how you can answer them. If you can answer this question, it means you have really learned. If you have any question as regards what I've explained so far, forward the questions to me personally on my WhatsApp or drop it on the group. I will answer it. And don't forget to subscribe to this channel so that you can get notification of anything that has been dropped on this channel. Thank you very much and have a beautiful day. God bless you.